All right, so here is the solutions for the second part of your review. Okay, so this is number 9 is very similar to number 8. So what we have here is the question is, what is the integral from 1 to 8 of 4 times g of x? So let's write that out. So I want the integral from 1 to 8 of 4 times g of x. So remember, another one of those little rules that we had is that if you have a constant, you can pull it out of the integral. So this is really 4 times the integral from 1 to 8 of g of x. So if I can find out what the integral from 1 to 8 of g of x is, then I just have to multiply by 4 and be done. So let's look at it. Okay, what we've got here is we've got the integral from 5 to 1 of 3 times g of x equals 9. Okay, I want the smaller number on the bottom, so I'm going to rewrite it as the integral from 1 to 5 of 3 times g of x equals, remember when we switch the boundaries like that, we have to switch the sign on the outside. Now you guys, a constant can come out, so this is really 3, do a little arrow there, 3 times the integral from 1 to 5 of g of x equals negative 9. And then I can get rid of this 3 by dividing both sides by 3. So that's going to give me that the integral from 1 to 5 of g of x equals negative 9 divided by 3, which is negative 3. So I'm really just trying to isolate the integral and the g of x by getting rid of all the fluff around it. Okay, so let's kind of draw this out. So far, I know that the integral from 1 to 5 of g of x was negative 3. So from here to here it was negative 3. Then it said that the integral from 5 to 8 of that same function was 4. But I want to know what the integral is from 1 to 8, so it's going to be negative 3 plus 4, which is just 1. Okay, so all of this equals 1, but then I have to multiply by 4 on the outside. 4 times 1 is 4. All right, this guy right here, midpoint sum. Okay, so let's look. We want 3 equal intervals from 0 to 6. So let's draw that out. 0 to 6, 3 equal intervals would split at 2. Okay, so our intervals are 0 to 2, 2 to 4, and then 4 to 6. Okay, now I've got to figure out which numbers to highlight. So let's look at the keywords here. I want a midpoint sum. My gosh, I keep clicking on the wrong things. Okay, I want a midpoint sum. So that means I need to highlight the middle of these two numbers. So the middle of 0 and 2 is 1. The middle of 2 and 4 is 3. The middle of 4 and 6 is 5. So these highlighted numbers are the numbers that are going to give me the heights. Okay, so let's go ahead and calculate this thing. I know that if I'm using midpoint or left or right Riemann sums, I'm going to be doing base times height, right? So I want to do base times height. So the base of this first rectangle is the distance from 0 to 2, which is 2. And the height I'm going to get is by plugging in this 1 into my equation. So I have this absolute value of x minus 4. If I plug in x equals 1, I'm going to get absolute value of 1 minus 4, which is the absolute value of negative 3, which is 3. So the height here is going to give me 3. Let's do the next one. So the base of this rectangle is the distance from 2 to 4, which is 2. And my height, again, I'm going to get from plugging 3 into here. So let's do that on the side here. Absolute value of 3 minus 4 is the absolute value of negative 1, which is just 1. So the height is going to be 1. And then last but not least, the distance from 4 to 6, that's your base, that's 2. And again, the height I'm going to get from plugging in 5 into here. So the absolute value of 5 minus 4 is the absolute value of 1, which is 1. Okay, now adding all these up, this is going to be 6 plus 2 plus 2, which is 10. All right, trapezoidal sum. Hey guys, this one's really ugly, so just bear with me, okay? All right, so I'm going from negative 1 to 2. That's right there, right? And then I want 3 equal intervals, so I need to divide this up into thirds, so it's going to be 0 and 1. So my intervals are negative 1 to 0, 0 to 1, and then 1 to 2. So again, what am I going to highlight this time? So because it's a trapezoidal sum, I'm going to have 2 different heights, which means that I need to highlight negative 1 and 0. I'm highlighting them both, and then 0 and 1, and then 1, and then 2. All right, how do I do this? The area of a trapezoid is 1/2 the base times height 1 plus height 2. Okay, so let's do this. For the first one, I'm going to have 1/2. The base is the distance from -1 to 0, which is just 1. Then height 1, how do I get height 1? Well, I get that by plugging -1 into here. So let's do that. I have e to the 2x. So this is e to the 2 times -1, which is e to the -2. And hey, let's just leave it like that because this looks really ugly. Then height 2, I'm going to get by plugging 0 into here. So this is going to be e to the 2 times 0, which is e to the 0, which is just 1. So I have that plus 1. So I got my first trapezoid. Now my next one, again, I have 1/2 times. The base is the distance from 0 to 1, which is 1. Height 1 I get by plugging 0 into my function, but you guys, I already did that here. No need to do it twice, right? So that equaled 1. And then height 2 I get by plugging 1 into my function. So that's e to the 2 times 1, which is just e squared. And then my last trapezoid, let me erase this arrow because I'm going to run out of room. Okay, I have plus 1/2. The base is the distance from 1 to 2, which is 1. And then height 1 I get by plugging in 1 into my function. But again, I already did that here, and that gave me e squared. And then plus, my gosh, I'm running out of room. If I plug 2 into my function, I'm going to get e to the 2 times 2, which is e to the 4th. Just going to try to plug that in there. Okay, let me make it bigger so you guys can see it. Now let's simplify this thing. It looks rather ugly. Okay, notice that they all have a 1/2 times 1. Okay, so I can pull that out of all of them. 1/2 times 1 is just 1/2 times, and what's left over? So what's left over is all of this stuff, right? So I'm just going to write down everything that's left over with plus signs in between. So it's e squared plus 1 plus 1 plus e squared plus e squared plus e to the 4th. And then maybe just combine some like terms. So this is 1/2. Wasn't the first one e to the -2? Look at that, catching a mistake. My goodness, I'm so sorry. So this is e to the -2. 1 plus 1 is 2. E squared plus e squared is 2e squared. And then I have this sad little e to the 4th at the end. All right, so that's about the best I could do with this without a calculator. Okay, let's look at 12. This is what we worked on in class today. Okay, so it's just find the original function f. So if I want to find the original function, I need to take the integral of both sides. Remember, an integral and a derivative are going to cancel each other out. So you're going to get f of x equals, the integral of 8x cubed is 8x to the 4 over 4. The integral of 12x is 12x squared over 2. And the integral of 3 is just 3x. And then I have that little c. Okay, let's do a little bit of cleanup. So I have f of x equals 8 over 4. That's going to give me 2x to the 4th. 12 over 2 is going to give me 6x squared. And then I have this 3x plus c. Okay, now look, I'm almost done. All I really need to do is find that c, and then I'm done. Okay, so I'm going to use my initial condition. So look, the initial condition says that if x equals 1, okay, I get 6. So f of x or whatever equals 6. Okay, so plugging that in, I'm going to replace all the x's with a 1. So that's going to give me 2 times 1 to the 4th plus 6 times 1 squared plus 3 times 1 plus c. And what does that equal? It equals f of x, but f of x, or the y value, is just 6. So let's calculate this. This is 2 plus 6 plus 3 plus c. So 6 equals, that's 11 plus c, so c equals -5. So replace the c with the -5 and you're done. So your original function was f of x equals 2x to the 4th plus 6x squared plus 3x, and the c was -5. So it's really the c that's going to give this problem away. Okay, taking the integral is not the hard part. It's the c that'll do it. All right, 13 is a little funky. I have a second derivative. That's okay though. So to get rid of a derivative, I'm going to take its integral, right? But it's only going to get rid of one of the derivatives. So I'm still left with f of theta. If that theta is really bothering you, change it to an x. It's the same thing. Okay, now the integral of sine of theta is, I'm sorry, this is still going to be an f prime, is negative cosine of theta. And the integral of cosine of theta is the sine of theta plus c. Now, I need to find that c, but notice I have an f prime here. What happened? I have an f prime here, so I'm going to be using this initial condition, which says that if x equals 0, then f prime of x equals 4. Okay, so let's go ahead and replace all of that. I'm going to replace, it's not x, sorry, it's theta this time, but whatever. So I'm going to replace all the thetas with 0. So negative cosine of 0 plus the sine of 0 plus c equals f prime of theta, which is this 4. Okay, and then what do we got here? Cosine of 0 is 1 with a negative in front is negative 1. Sine of 0 is 0 and then plus c. So if I add 1 to both sides, I'm going to get that c equals 5. Okay, so let's go ahead and replace that with a 5 and see what we get. So my new function now is f prime of theta equals negative cosine of theta plus sine of theta plus 5. All right, not quite done yet though. I want the original function, which is f, not f prime. So I'm going to integrate this again. Okay, an integral and a derivative cancel out. So I have f of theta now equals, and I have this negative sign, and the integral of cosine is sine. So notice I just brought that negative 1. I can even pull it out of the integral if I wanted to. And then the integral of sine is negative cosine. And then I have the integral of 5 is 5x, but my x is really a theta. So this is 5 theta plus some other constant. Now, because I'm dealing just with f this time, I'm going to use this initial condition. So it's saying that if theta is 0, f of theta equals 3. So let's plug in 0 again. Negative sine of 0 minus the cosine of 0 plus 5 times 0 plus c. What does it equal? It equals 3. So I have 3 equals, the sine of 0 is 0, that's gone. Cosine of 0 is 1 with a negative in front is negative 1. 5 times 0 is gone, so plus c. If I add 1 to both sides, I'm going to get c equals 4. So all I need to do to get my final answer is replace this c right here with a 4. So I'm going to get that f of theta equals negative sine theta minus cosine theta plus 5 theta plus 4. That's a fun little question, wasn't it? All right, number 14. This one's a little interesting. This one looks awful, but it's not that bad. Okay, so same idea. I'm going to integrate both sides. That'll get rid of one of these derivatives for me. I know that the integral of 2 is 2x, and the integral of 12x is 12x squared over 2, which reduces to 6x squared plus c. Okay, now here's the problem. A lot of people came in actually at brunch and lunch and said, is there a typo? And what they were saying, they said, look, I have an f prime, but I don't have an f prime in my initial conditions. It's actually not a typo. You just got to keep going. You can't plug them in, right? So you just got to keep going. So let's do it again. Let's take the integral again. Then this is going to cancel. So I'm going to get f of x equals, the integral of 2x is 2x squared over 2, or x squared. The integral of 6x squared is 6x cubed over 3, or 2x cubed. The integral of c, a constant, is just going to be the c with an x tagged onto it, and then it's going to have another constant added to it. Now, to decipher between the c and another constant, I'm just going to call this new constant a d. Okay? Now, because I'm at an f of x, I have two initial conditions that I can actually plug in. Now, the question is, which one should I plug in? I'm going to go with this one first because I want x to equal 0. So it says if x equals 0, f of x equals 9. Okay, so f of x is 9. If I make x equal to 0, look what's happening. It's wiping everything out, is it not? So all this gets wiped out and we get that d equals 9. So if I know that d equals 9, I can replace this d with a 9, giving me that f of x is x squared minus 2x cubed plus cx plus 9, right? Now, all I have to do is find that c. Well, now I can use my other initial condition to do that. It says if x is 2, then f of x is 15. So this is going to be 15 equals, replacing all the x's with a 2, 2 squared minus 2 times 2 cubed plus c times 2 plus 9. So it's going to be 15 equals 4 minus 16 plus 2c plus 9. So 15 equals, let's see, 4 minus 16 is negative 12. Negative 12 plus 9 is negative 3 plus 2c. If I add 3 to both sides, I'm going to get 18 equals 2c. If I divide by 2, I'm going to get that c equals 9. Okay, you guys, do you think these have to be the same? No, that was a total coincidence. So replacing this c with a 9 right here, it's going to give me my final answer, which I'll do in purple. F of x equals x squared minus 2x cubed plus 9x plus 9. Okay? And the last little fun one here, write Riemann sum with tables. Okay? So what are my intervals? My first interval is 1 to 5. Then I've got 5 to 6. Then I've got 6 to 8. Is there another one? Oh, there is. Look at that. And 8 to 10. Oh my gosh. Okay, I can't write like this anymore. Let's try this again. 6 to 8. And then 8 to 10. All right, now I want to write Riemann sum. So that means I want to highlight all the right ones, all the ones on the right. And whatever's highlighted, that's what's giving you your height. Okay, a right Riemann sum, the area is going to be base times height. So the base, the distance from 1 to 4, 1 to 5 is 4. And the height at 5, here is going to be 11. Then plus the distance for the base 5 to 6 is 1. The height at 6 is going to be 7. Plus the distance from 6 to 8 is 2. That's my base. The height at 8 is going to be 3. And then last but not least, the distance from 8 to 10 is 2. The height at 10 is going to be negative 4. And a negative height just means that it's below the x-axis. Okay, so this is going to be 44 plus 7 plus 6 minus 8. 44 plus 7 is 51 plus 6 minus 8. 51 plus 6 is 57 minus 8 is 49. Woohoo! All right. Hey, you guys, tomorrow, some very easy questions. Okay. Know your Riemann sums, know left, right, midpoint, trapezoid. There's a lot of that on there. Some very basic integrals. These guys right here, know number 12, number 13, and 14. Not so much tomorrow, but you should really know them for later. All right. If you have any questions, we have 20 minutes tomorrow to go over them. Okay. Have a good night.